Today we will discuss thermodynamics. What is thermodynamics? Thermodynamics is that branch of physics that deals with the study of mutual conversion of heat and mechanical energy and their interrelation. When heat is converted into external work or when work is done, some heat is produced, right? There exists a correlation between them, right? And that correlation, the study of those correlation is known as thermodynamics. There are three laws of thermodynamics. The first law of thermodynamics is that, sorry, there are two laws of thermodynamics. The first law of thermodynamics, it is that W proportional to H, which means heat produced when work is done, is directly proportional to the work done. That was the first law, but Clausius gave us a more general form of first law of thermodynamics, and that's why we have used the Clausius statement. Clausius stated that the amount of heat supplied to a system is used by the system in two ways. First, to increase its internal energy, and some part of it is used to do, and the rest part is used to do some external work. Now, if the internal energy of the system is denoted by U2 minus U1, which means that initially the temperature, or initially the you may take as temperature, initially the temperature of the system was U1, and after heat has been supplied to the system, its temperature has begun to come to U2, and U2 minus U1, it is the amount of work done proportional to that temperature, that is the internal energy change, and W is the work done, and Q is the amount of heat supplied to the system. So if we supply Q amount of heat to a system, then what happens? The system takes some energy, some heat energy, and that energy it uses to increase its temperature, right? That is the increase its internal energy, right? The manifestation of internal change in internal energy or increase in internal energy is by increasing its temperature, and the rest of the heat energy is used for doing some external work. The very good example of this first law of thermodynamics is that uh, suppose some work has been given to a contractor, right? And some amount of money has been given to the contractor to, or for example, you take you are building a house and you have given X amount of rupees to a contractor to build the house. What does the contractor do? The contractor, out of that X amount, he takes out Y amount, and that is his profit, Y amount as his profit, and the rest X minus Y money he uses to build your house. So that Y amount which he has taken as his profit is the change in his internal energy. His bank balance has increased, right? So suppose now the system is your contractor and you are giving heat, which was money in that case. And so if you give heat to a system, it will increase its internal energy by using some amount of that money, and the rest amount of that heat will be used for doing external work. Internal energy of a given amount of gas, it depends only upon its temperature, right? It depends only upon its temperature and is independent of its pressure and volume. Very important point to remember, that internal energy of a given amount of gas depend only upon its temperature and is independent of its pressure and volume, right? Now this statement holds only for ideal gases, right? This statement holds only for ideal gases, but in practice you do not have any ideal gases. So for real gases, the internal energy is found to depend on its volume, right? But the effect is very small, right? So the effect is very small, so that it can be neglected. Okay, so that it can be neglected.